Historically, there have always been two different routes for steelmaking. The first one uses blast furnaces and iron ore as raw material. The second one, which is the one that we have here in SIDENOR, uses instead an electric arc furnace and mainly scrap as raw material. These two routes have coexisted for many years, but the current challenges towards decarbonization are changing the situation, as many blast furnace steelmakers are now transitioning to electric arc furnace. This makes sense given the huge difference in emissions between one method and the other, but this tendency also leads to an increasing shortage in scrap, as there is now a higher demand and the supply remains the same. Besides, this shortage is higher in cleaner scraps, leaving us with those with higher residual elements such as copper, which is negative for the steel properties and very difficult to remove. This is why it is now necessary to be as efficient as possible when managing our scraps for the melting process. In this sense, we expect that the dynamic and adaptive models developed in the s-X-AIPI will help us improve the ones that we already have. SIDENOR receives more than 4,000 tons of scrap every day, which makes it very difficult to address the real variation that might exist among the same types but different batches. As said before, it has always been difficult to characterize the different types of scrap and evaluate the impacts in the electric arc furnace. The developments in this project, such as self-abilities, autonomous manager, which are being implemented in the steel use case by our colleagues from BFI and MSI, will aid in specific aspects, being one of them the dynamic calculations of copper amount for our different scraps. These developments will definitely help us adjust to this complex scenario, keep on producing higher quality steel, and continue on the path towards reducing our CO2 emissions.